The underlying mysteries of life, from childhood to death, involve the complex interplay between biological, psychological, and philosophical processes. From infancy to adulthood, human beings undergo rapid physical and cognitive changes driven by genetic expression and environmental interactions. Childhood represents a critical period when these changes are most pronounced. For instance, the brain undergoes extensive development and neural connections form in response to experiences. Attachment theory, which posits that early relationships shape later social behaviors, provides insights into how childhood attachments impact an individual's ability to form lasting bonds. The transition through various life stages, from adolescence to adulthood, involves navigating new challenges and opportunities, with each stage presenting different adaptive demands. Philosophically, these mysteries extend beyond the observable realms of science and psychology. Questions about purpose and meaning in human existence remain enigmatic. Jean-Paul Sartre's philosophy that existence precedes essence suggests that individuals define their own nature through actions rather than predestined roles or characteristics. The concept of self-identity and consciousness, which are central to this narrative, remains a subject of ongoing debate. These biological, psychological, and philosophical mechanisms operate in concert but remain deeply mysterious. How do genetic, environmental, and experiential factors combine to shape human life from birth to death? The exact definitions and hidden assumptions inside these mysteries await further exploration. For instance, the concept of a critical period in early development is well established. During this time, certain experiences or stimuli have profound effects on brain structure and function. A child's brain undergoes extensive changes, particularly in areas responsible for sensory processing, neural connections, and emotional regulation. This period sets the foundation for later cognitive abilities and emotional resilience. Psychologically, early relationships play a significant role in shaping an individual's narrative identity. Attachment theory, pioneered by John Bowlby, highlights how infants form bonds with caregivers that influence their sense of security, trust, and self-worth. These foundational connections can either support or hinder the development of healthy social behaviors and emotional regulation throughout life. From a biological standpoint, genetic factors interact dynamically with environmental influences to sculpt an individual's physical and mental traits. For example, epigenetic modifications, changes in gene expression without altering the DNA sequence, can be influenced by exposure to stress, nutrition, and other environmental conditions. These changes can have lasting impacts on health later in life. Philosophically, these transitions from childhood to death raise profound existential questions about identity and purpose. Sartre's notion of existence precedes essence suggests that individuals must define their own meaning through choices and actions, rather than conforming to predetermined roles or identities imposed by society. This perspective challenges the idea that one's life is simply a linear progression from birth to death, but rather an ongoing process shaped by personal agency. These definitions create a complex web of overlapping processes and subjective experiences. The exact mechanisms driving these changes are still subjects of active research and debate, making them rich areas for continued exploration in both scientific and philosophical domains. From a biological standpoint, the period between infancy and childhood is marked by rapid physical development, particularly in neural connections and sensory processing centers like the visual cortex and the auditory brainstem. For example, newborns develop their vision over time as they experience different light intensities and wavelengths, leading to the formation of complex visual pathways that mature through repeated exposure. Philosophically, individuals must navigate this dynamic process by defining their own narrative. Jean-Paul Sartre's existentialism posits that one is condemned to be free, a concept that challenges the idea of a predetermined path from birth to death. Instead, each individual must create their own meaning and purpose in life based on these evolving experiences. In contrast, some argue for a more deterministic view, suggesting that genetic factors play a significant role in shaping an individual's development and behavior even before birth. This perspective highlights how prenatal conditions can influence brain structure and function, setting the stage for later psychological outcomes like temperament or cognitive abilities. These competing interpretations raise important questions about the balance between nature and nurture in human development. Whether driven by biological necessity or shaped through complex interactions with the environment, the underlying mysteries of life from childhood to death continue to captivate scientists and philosophers alike. In examining the underlying mysteries of life from childhood to death, one significant boundary case involves individuals born with minimal neural tissue, such as those affected by hydranencephaly. In these cases, despite extensive care and environmental input, cognitive development is severely limited or absent. Another counter-example comes from the phenomenon of neuroplasticity, which allows the brain to reorganize itself throughout life in response to learning, experience, and physical exercise. This demonstrates that the critical period concept is not absolute. While early experiences have a profound impact, the brain retains plasticity even into later stages of life. From a philosophical standpoint, existential thinkers like Jean-Paul Sartre explored the idea that individuals must define their own existence through choices and actions throughout their lives. However, this view faces challenges from biological determinism, which posits that genetic and environmental factors set limits on what an individual can achieve or become. These counterexamples and boundary cases challenge our understanding of linear progressions in cognitive development and existential self-definition, revealing the complexity and interdependence of biological, psychological, and philosophical dimensions. The exact mechanisms driving these processes continue to be explored, as scientists and philosophers seek to unravel the intricate web of influences that shape human life from childhood to death. One fascinating boundary case is provided by individuals who experience atypical development or significant brain injuries later in life. For instance, research on adults with traumatic brain injuries has shown instances where cognitive recovery occurs unexpectedly, indicating that neuroplasticity may extend beyond traditional critical periods. This challenges the notion of a strict biological timeline and suggests that certain regions of the brain can still adapt and reorganize themselves to some extent. Another boundary case is found in studies of feral children who were isolated from human interaction during formative years. These cases highlight the critical role early relationships play in social and cognitive development, but also illustrate the limits of brain plasticity once windows of opportunity close. This complexity underscores that developmental processes are not always linear or strictly tied to biological timelines. They depend on a myriad of factors, including genetic expression, environmental interactions, and individual resilience. These counterexamples push against the idea that all developmental processes follow predictable paths, inviting us to question our assumptions about critical periods and the plasticity of the human brain. They prompt deeper exploration into the exact definitions and hidden assumptions guiding our understanding of life's mysteries from childhood to death. During critical periods in early development, particularly between the ages of 2 and 4, a child's brain undergoes extensive changes. This is when neural connections are forged rapidly, especially in areas responsible for sensory processing and emotional regulation. These changes set the foundation for how a child perceives and interacts with their environment, For instance, early experiences can either enhance or impair the development of these critical circuits. The work of neuroscientist Patricia Kuhl highlights this. She has demonstrated that infant brains are highly sensitive to language input during these periods, suggesting that missing out on certain sounds and rhythms could have lifelong consequences for language acquisition. In psychological terms, the quality of early relationships shapes an individual's sense of self and behaviors in later life. For example, John Bowlby's attachment theory posits that secure attachments formed in childhood are a strong indicator of good mental health outcomes. However, insecure or disorganized attachments can lead to difficulties in emotional regulation and social interactions throughout one's lifetime. From a philosophical perspective, these early experiences prompt deeper exploration into the concept of identity formation. The idea that individuals must define themselves through ongoing processes shaped by both biological and psychological factors poses significant challenges for understanding existential questions about selfhood. For instance, how does an individual's sense of self evolve from childhood to adulthood, given the interplay between innate traits and learned behaviors? From early childhood, the brain is a dynamic landscape where experiences begin to shape identity. As children grow, they form attachments and learn behaviors that define their sense of self. By adolescence, teenagers face existential questions as they navigate personal identities in the context of peer pressure and societal expectations. Their brains continue to develop, particularly in areas related to emotional regulation and cognitive control, making them highly vulnerable to external influences. In old age, these existential questions take on a different hue. The acceptance of mortality becomes a central theme as individuals reflect on their lives and prepare for the inevitable end. This transition challenges the linear progression from birth to death, prompting deeper philosophical inquiries about the meaning of life and the nature of existence. A key mechanism in this process is neuroplasticity, the brain's ability to change and adapt. Throughout childhood and adolescence, neural connections are formed and refined based on experiences. In old age, while some cognitive functions may decline, residual plasticity allows for adaptation. This ongoing reshaping of the brain influences how individuals perceive themselves and their place in the world. By examining these stages through the lens of Sartre's existence precedes essence, we can see that at each life stage, existential questions evolve. From childhood to adolescence, the focus is on forming a sense of self based on experiences, while in old age, acceptance of mortality becomes paramount. This continual process, driven by neuroplasticity and influenced by environmental factors, shapes our understanding of existence itself. The next movement will explore an unexplored layer 8, new mechanisms and evidence in the complex interplay between biological and existential processes. In exploring layer 8, we examine epigenetic modifications that shape cognitive and emotional development. These changes occur through environmental influences such as stress and nutrition, altering gene expression without changing DNA sequences. For instance, a child who experiences adverse conditions during sensitive developmental phases may exhibit altered neural plasticity and reduced cognitive resilience. Psychological studies have shown that early relationships play a significant role in shaping brain function. An individual's exposure to stress or nutrition can lead to epigenetic changes, affecting the structure and connectivity of key areas involved in emotional regulation. Ethical considerations arise when considering interventions to alter these processes for therapeutic benefits. The question becomes, how far should we go in manipulating these mechanisms without understanding their long-term consequences? Michael Meany from McGill University explores specific ethical considerations and the boundaries of such interventions. raising questions about where we draw the line between enhancing human potential and intervening too deeply into the natural course of development. The brain's rapid development during early childhood is driven by both genetic and environmental factors, but recent research has highlighted the role of epigenetic modifications in shaping this process. These changes do not alter the DNA sequence itself, but can influence gene expression without altering it, thereby affecting how genes are turned on or off. For instance, a child's experiences with stress can lead to different patterns of epigenetic marks that persist into adulthood and may even be passed down to future generations through a phenomenon known as transgenerational epigenetic inheritance. Studies have shown that early life traumas can result in heightened sensitivity to stress later in life due to altered gene expression. This can manifest physiologically, such as increased levels of cortisol, the hormone associated with stress responses. These epigenetic modifications can thus serve as a bridge between genetic predispositions and environmental influences, offering new insights into why individuals respond differently to similar environments. This raises profound questions about the extent of our plasticity during these formative years, and how society should approach interventions aimed at enhancing human potential without overstepping ethical boundaries. Epigenetic modifications play a critical role in shaping the mysteries of life from childhood to death. For instance, DNA methylation and histone modification can silence or activate genes without changing the underlying sequence itself. This flexibility allows for rapid adjustments in gene expression in response to environmental cues, particularly during early development. This dynamic interplay challenges a purely deterministic view where genetic factors predominate. Instead, it suggests that our environment actively shapes who we become. Consider the case of identical twins, whose genetic makeup is nearly identical yet can exhibit divergent behaviors and traits as they age. Differences in environmental exposures, such as educational opportunities or social experiences, can lead to epigenetic changes that modify gene expression without altering DNA sequence. This raises profound questions about the extent of our plasticity during these formative years. From a psychological perspective, early relationships profoundly shape an individual's development, influencing their ability to form secure attachments and navigate social interactions later in life. These early experiences can also trigger epigenetic modifications that affect stress response systems, impacting mental health outcomes throughout adolescence and into adulthood. The role of epigenetics thus extends beyond mere biology. It intertwines with psychological processes, illustrating how our past influences the present. While interventions can potentially mitigate genetic risks or enhance cognitive abilities, they also carry the risk of unintended consequences and societal disparities in access to such technologies. The balance between advancing scientific knowledge and safeguarding individual well-being remains a critical debate. This exploration into the role of epigenetics underscores the intricate relationship between our biological heritage and environmental influences from childhood to death, setting the stage for deeper philosophical reflections on human development and identity. The concept of mortality significantly shapes individual identity and purpose, a perspective that is highlighted by the psychological impact children experience as they begin to understand their own finitude. This awareness can lead to anxiety or a deeper engagement with life's meaning. Philosophers like Paul Sartre explored how mortality defines freedom and responsibility. He argued that we are condemned to be free, facing the inevitability of our end while striving for authenticity in the face of our own mortality. From a biological standpoint, early relationships profoundly influence neural development. For instance, during the critical period when infants form attachments with caregivers, these bonds shape emotional regulation and cognitive function. The brain undergoes extensive maturation during childhood, particularly in areas related to sensory processing and emotional integration. This dynamic process challenges the deterministic view that genetic factors alone determine our destiny. Instead, it highlights the interplay between nature and nurture. As children grow, they begin to understand that every action has consequences, including their own mortality. This understanding can lead to ethical considerations about how individuals should live in light of their limited time on Earth. For example, a child's concern for fairness or justice might stem from these reflections on life's finite nature. Different societies have varying beliefs about death and the afterlife, which can influence how individuals navigate their own mortality. For instance, in some cultures, there is a strong emphasis on honoring ancestors and maintaining community ties, while in others, an individual's legacy might be seen through personal achievements rather than familial connections. These cultural differences illustrate how societal contexts profoundly impact psychological development and philosophical reflections on life's purpose. This complex interplay between individual experiences and broader cultural influences sets the stage for deeper explorations into human identity and meaning. Consider, for instance, the role of schooling in shaping a child's academic trajectory and social skills. The way education is structured, whether it emphasizes rote memorization or critical thinking, can significantly impact how children perceive their abilities and future prospects. This framework often aligns with broader societal values. In some cultures, there is an emphasis on early academic achievement as a path to success, while others prioritize holistic development that includes emotional resilience and social connectedness. Psychologically, these cultural norms can shape the narratives individuals tell themselves about their potential and limitations. A child raised in a culture that stresses individual competition might develop a sense of self-efficacy tied to personal achievement, whereas one from a community-focused background may find identity through group success rather than individual accolades. These internalized beliefs are not predetermined, but are influenced by the social structures around them. For example, genetic editing technologies like CRISPR raise questions about the ethics of altering an embryo's DNA to influence traits such as intelligence or health. These technologies can be seen as tools for enhancing human potential, but also as interventions that could lead to unforeseen consequences. The ethical considerations surrounding the use of biotechnology in human development are complex and multifaceted. For instance, gene editing techniques such as CRISPR-Cas9 allow for precise modifications to an individual's genetic makeup with the potential to correct or prevent inherited diseases. However, this raises significant philosophical questions about the moral limits of altering human traits. Philosophers like Michael Sandel argue that such interventions could lead to a form of genetic engineering that might create unfair social inequalities by giving advantage to those who can afford such treatments. Neuroscientific research also presents ethical dilemmas. Functional magnetic resonance imaging and electroencephalography are non-invasive tools used to measure brain activity, providing insights into cognitive processes and neurological disorders. While these technologies have advanced our understanding of the brain, they also raise concerns about privacy and consent. There is a risk that the data collected could be misused or misinterpreted, leading to unintended consequences. Artificial intelligence in healthcare further complicates ethical issues. AI algorithms can predict develop mental outcomes with high accuracy, which has the potential to revolutionize early intervention strategies for children at risk of certain conditions. However, there is a danger that these predictions might reinforce existing biases and lead to over-reliance on technology rather than human judgment. These technologies challenge our philosophical understandings of what it means to be human and raise critical ethical considerations regarding the limits of intervention and the potential for misuse. The complexity of these issues underscores the need for rigorous ethical frameworks to guide their application, ensuring that they do not compromise individual rights or exacerbate existing inequalities. For instance, secure attachment styles developed during infancy tend to predict healthier interpersonal relationships later in life, which is supported by a large body of psychological research. Philosophically, these early experiences set the stage for deeper existential questions about identity and self-determination. Sartre's notion of existence precedes essence challenges the idea that one's nature is solely determined by genetic or environmental factors. Rather, it posits that individuals must actively construct their own identities through choices and actions. This perspective highlights how both internal biological drives and external social influences interact to shape an individual's path. Biologically, this dynamic interplay can be observed in the brain's development during early life. Similarly, the auditory brainstem develops through exposure to various sound patterns and intensities, underscoring the importance of environmental stimuli in sculpting cognitive capabilities. This period is marked by critical transitions that challenge more deterministic views of human development. The complexity of these mechanisms underscores the need for rigorous ethical frameworks to guide their application, ensuring they do not compromise individual rights or exacerbate existing inequalities, a point raised earlier. Neuroplasticity, the brain's ability to change its structure and function in response to new experiences, is a fundamental mechanism underlying lifelong learning and adaptation. This process begins early in life, as neural connections are shaped by environmental stimuli and genetic predispositions. For instance, children who learn to play an instrument experience changes in their brain's auditory cortex, enhancing their perceptual abilities related to sound. As individuals mature into adulthood, neuroplasticity continues to influence cognitive flexibility and resilience. People recovering from brain injuries or learning new skills like a second language often exhibit dramatic improvements because of the brain's capacity to reorganize itself. This dynamic process is not limited to sensory processing. It extends to memory formation and emotional regulation. However, there are boundary cases where neuroplasticity can have both positive and negative impacts. For example, individuals with chronic stress may develop hyperactive neural circuits that contribute to conditions like anxiety or depression, highlighting the dual nature of this adaptive mechanism. The complexity of these processes underscores the need for continued research into how best to harness neuroplasticity without unintended consequences. This understanding bridges early developmental biology with lifelong cognitive functions, illustrating the enduring mysteries and challenges in interpreting how individual experiences shape our lives from childhood through to death. As children grow from infancy into adolescence, their brains undergo numerous changes influenced by both genetic factors and environmental influences. For instance, early life traumas can lead to lasting epigenetic alterations, which affect behaviors and cognitive functions later in life. This dynamic process of the brain continually reshaping itself raises profound existential questions about identity and free will. The brain's plasticity also highlights ethical considerations involving interventions that might manipulate neuroplasticity. Recent studies have shown that different hormones can play a significant role in these processes, acting as bridges between genetic predispositions and environmental influences. These mechanisms are not static, but continue to evolve throughout life, making the study of neuroplasticity essential for understanding how individual experiences shape our lives from childhood through to death. The extent to which early life traumas influence brain structure is a topic ripe with complexity and controversy. Some researchers argue that certain traumatic events can rewire neural circuits in ways that persist into adulthood, while others suggest that the brain has mechanisms to recover and adapt over time. These competing perspectives underscore the nuanced nature of neuroplasticity and its impact on lifelong learning. As we explore how consciousness influences our perception and interpretation of the passage of time from childhood to death, we are reminded of the ongoing reshaping of neural pathways that underpin our experiences. This continuous process is a central theme in understanding the mysteries of life, making it an essential facet of human existence. This continuous process is driven by both genetic and environmental factors that influence development at each stage of life. The brain's visual cortex undergoes significant changes as the infant learns to interpret visual information from the environment. Similarly, the auditory brainstem develops through repeated exposure to sounds, helping the child make sense of their acoustic world. As children grow older, their cognitive skills advance, allowing them to navigate more complex social and physical environments. These changes are essential for the child's survival and adaptation in their specific environment. Ethically, these insights into evolutionary mechanisms challenge us to think deeply about how we support children as they grow. The question arises, how do our societies shape the development of young minds? Do we provide the necessary conditions for optimal growth, or merely align with the predetermined paths set by genetics? The exact mechanisms driving changes in temporal perception remain complex and not fully understood, highlighting the need for further research. As we explore these complexities, we gain deeper insights into the nature of consciousness and its role in shaping our experiences from childhood to death. As infants grow, their brains undergo extensive reorganization, particularly in the visual and auditory systems. For instance, newborns develop their vision through repeated exposure to different light intensities and wavelengths, which triggers the maturation of complex visual pathways. This process is not solely driven by genetic factors, but is also influenced by environmental interactions. The auditory brainstem, similarly, undergoes significant changes as infants learn to process sounds in their environment. Genetic predispositions can significantly shape an individual's physical development and cognitive abilities from very early on. For example, certain genes influence the timing of puberty, which can vary widely among individuals. Genetic factors also play a critical role in the development of neural connections that underlie learning and memory. While these genetic influences are powerful, they do not predetermine a fixed path of development. Instead, they interact with environmental conditions to shape outcomes. The interplay between genetics and environment is evident even during fetal development. Studies have shown that prenatal exposure to various environmental factors, such as maternal stress or nutrition, can affect the expression of certain genes in the developing fetus. This means that the genetic blueprint alone does not determine an individual's physical and cognitive traits. It must interact with external influences. These complexities are further highlighted by psychological studies, which show how early relationships significantly shape individual development. For instance, secure attachments formed during infancy can have lasting impacts on emotional regulation and social behaviors in later life. Philosophical interpretations also contribute to our understanding of these mysteries, exploring questions about identity formation and the role of consciousness throughout one's lifespan. The balance between genetic predispositions and environmental influences explains why individuals with similar genotypes can develop differently based on their unique experiences. This dynamic process underscores the underlying mysteries of life from childhood through death, revealing how biological mechanisms interact with psychological and philosophical dimensions to shape individual trajectories. The brain undergoes extensive restructuring during early childhood, a process that is both complex and influenced by genetic predispositions. Certain gene variants can predispose individuals to specific cognitive or behavioral traits, which may manifest or modify over time due to environmental influences. For instance, the expression of genes associated with stress regulation can be epigenetically altered in response to trauma experienced during early life. This means that while a child might inherit a genetic trait, making them more susceptible to anxiety, their actual susceptibility could be heightened by traumatic experiences, such as neglect or abuse. These changes are not solely deterministic. They open the door for agency and choice. A child who inherits genes associated with academic success may still underperform in school due to poverty or poor educational environments. Conversely, a child with genetic predispositions towards lower cognitive abilities might excel academically through supportive schooling and parental involvement. The dynamic interplay between nature and nurture underscores how individual development is not predestined but shaped by both biological and environmental factors. This understanding also highlights the ethical complexities involved in genetic research, particularly regarding predictive genetic testing for conditions like schizophrenia or autism. While such tests can provide insights into potential future health issues, they do not guarantee specific outcomes due to the influence of environmental factors. The existence of these tests raises questions about how individuals should interpret and act upon their genetic information. The psychological impact of historical events on life mysteries can be seen in the way individuals interpret and cope with trauma or change. For example, a child growing up during World War II might develop different cognitive frameworks compared to someone born in peacetime. The stressors of war can lead to epigenetic changes that alter gene expression related to stress responses. Studies have shown increased DNA methylation in survivors of major traumas. This mechanism challenges the purely deterministic view, as environmental factors can modify genetic functions without changing the underlying code. In adolescence, these early experiences can shape an individual's narrative and concept of self, influencing how they confront life's complexities. Ethical considerations arise when advancing scientific knowledge about epigenetics must consider respecting individual autonomy. It is a critical debate in understanding the extent to which our environment controls who we are, or if there remains some flexibility for free will. Thus, historical events can affect an individual's epigenetic profile and cognitive development. The balance between advancing scientific knowledge and protecting individual rights becomes essential as we continue to explore these relationships. This facet underscores how history, biology, and psychology collectively shape one's experience from childhood to death. A new mechanism, limit, or body of evidence awaits unexplored layer 20, one of mysteries of life. As individuals grow from childhood into adolescence, the maturation of mirror neuron systems plays a critical role in developing empathy. These neurons become more specialized during this period, allowing for better emotional understanding and social interaction. Psychological studies reveal that children who engage in interactive play and social activities exhibit stronger empathetic responses later in life. For instance, a study by Dissetti and colleagues demonstrated that early exposure to cooperative games enhances mirror neuron activity, facilitating the ability to understand others' emotions. Biological mechanisms suggest this development is influenced by both genetic predispositions and environmental interactions, particularly quality early relationships. Philosophically, This raises existential questions about the origins of moral behavior and the role of empathy in societal functioning. Ethical considerations arise regarding how to nurture these neural pathways effectively during critical developmental periods. For example, the exact timing and extent of mirror neuron maturation vary among individuals, introducing uncertainty into predicting long-term empathetic abilities. This new territory opens by highlighting the dynamic interplay between biological maturation, social engagement, and moral development from childhood through adulthood, challenging deterministic views that genetic factors alone predominate this process. This bridge invites exploration into how nurture and nature combine to shape empathetic capabilities later in life, setting the stage for further investigation into the mechanisms underlying emotional intelligence across different developmental stages. Sleep, a period when the body and mind retreat into a state of rest, plays a critical role in integrating life experiences from childhood to death. During sleep, particularly during deep stages like rapid eye movement and non-REM sleep, the brain consolidates memories, processes emotions, and integrates new information with existing knowledge. For instance, during REM sleep, vivid dreams can replay fragments of experiences or scenarios, allowing for emotional regulation and integration. Studies have shown that sleep deprivation impairs memory consolidation, suggesting a direct link between the quality of sleep and cognitive function over time. This is particularly important in early childhood, where brain development is rapid and vulnerable to disruption. Psychological theories propose that this integration during sleep helps shape an individual's personality and emotional resilience. For example, if a child experiences a traumatic event, the reactivation of neural circuits related to stress during sleep can facilitate better coping mechanisms by reinforcing or modifying responses to similar stimuli in later life. This mechanism challenges the purely deterministic view of development, indicating that environmental factors play a dynamic role even at early stages. As we age, these processes continue to influence our emotional and cognitive landscapes, contributing to changes in empathy, stress response, and overall mental health. For example, a study by Dr. Alan Hobson at Harvard Medical School found that sleep deprivation can lead to heightened emotional reactivity and impaired memory consolidation, affecting how individuals process experiences from childhood into adulthood. During REM sleep, the brain's neural activity mimics waking life, allowing for the reactivation of emotional memories. This is particularly relevant in later life, where individuals may revisit and integrate long-standing emotional experiences. The philosopher Iris Murdoch once wrote that the human animal grows more aware of its own limitations by living, suggesting that over time, our sleep patterns and their effects on memory consolidation play a role in how we come to terms with these limitations. The exact mechanisms driving this integration remain complex and not fully understood. For instance, the neuroscientist Jai Zhang at Stanford University has explored the role of synaptic plasticity during sleep, an adaptive process where the strength of neural connections changes based on experience. In older adults, patterns of sleep can vary considerably. Some may find themselves experiencing more fragmented or lighter sleep, which could affect how well they integrate new experiences and manage emotional challenges. Near-death experiences have been reported by individuals who survived life-threatening situations but offer a fascinating lens through which to examine the human experience, and these often involve feelings of peace, unity with all things, and a sense of transcending physical form. These experiences can profoundly shape one's understanding of life and death, challenging conventional perspectives on mortality. For example, Elizabeth Kubler-Ross, in her seminal work on death and dying, described how near death experiences can lead individuals to reevaluate their lives and place greater emphasis on spiritual or existential dimensions. Near-death experiences can profoundly impact an individual's understanding of life and death. From a psychological perspective, NDEs often report feelings of peace, unity with the universe, or encounters with deceased loved ones. These experiences challenge personal beliefs about mortality and existence, prompting individuals to explore deeper existential questions. Philosophically, NDEs raise significant questions about consciousness and its potential continuation beyond physical death. They invite consideration of whether there are unseen aspects in life that extend beyond what is immediately observable. Biologically, studies suggest that NDEs may be linked to changes in brain activity during near-death situations, such as increased blood flow or altered neurotransmitter levels. For instance, the release of certain hormones and neurotransmitters like serotonin can alter perceptions and lead to these intense experiences. Ethically, NDEs prompt a critical debate on how society should view death and dying, including afterlife beliefs. Some individuals report heightened senses of purpose following NDEs, while others may experience anxiety about their mortality. The psychological impact of NDEs varies. Some people embrace newfound meaning in life, whereas others may struggle with the implications. Consider the case of Raymond Moody, who popularized the concept of near-death experiences through his book Life After Life. His work has influenced numerous discussions on consciousness and its continuation after death. Overall, near-death experiences offer insights into the complex relationship between consciousness, existence, and human experience. They challenge us to reconsider our understanding of life's mysteries from childhood to death, inviting exploration into the intricate balance between biological mechanisms and existential questions. Epigenetic changes during childhood and beyond can dramatically alter gene expression, influencing aspects of brain development and function. For instance, nutritional deficiencies in early life can lead to methylation patterns that affect the wiring of neural circuits, potentially impacting cognitive abilities later on. In contrast, a rich and supportive environment might promote positive epigenetic markers that enhance learning capacity and emotional resilience. Research by Michael Meany and his team at McGill University has shown that changes in maternal care behaviors during early life can have lasting effects on the offspring's stress response systems. Prolonged periods of neglect or poor nurturing can result in elevated cortisol levels, a marker of chronic stress, even into adulthood. Conversely, consistent and positive interaction can lead to better regulation of these systems. The question becomes whether these changes are merely reflective of an individual's experiences, or if they actively contribute to shaping their developmental trajectory. This interplay between environmental factors and genetic expression raises profound existential questions about the extent to which our lives are determined by our biological makeup versus our surroundings. It challenges us to reconsider our understanding of life's mysteries from childhood to death, inviting exploration into the intricate balance between biological mechanisms and existential considerations. The flexibility of epigenetic processes allows for gene expression changes in response to environmental factors, challenging a purely deterministic view. For example, DNA methylation can silence specific genes without altering the underlying sequence itself, while histone modification can either loosen or tighten chromatin structure to influence gene activity. This dynamic interplay between genetic predispositions and environmental influences raises profound questions about personal responsibility and autonomy. Philosopher Paul Sartre explored these themes in his work, emphasizing that individuals must actively define their meaning within a world devoid of inherent purpose. Early relationships significantly shape an individual's ability to navigate life's challenges, with evidence from psychological studies showing how secure attachment can foster resilience. Conversely, childhood adversities can alter gene expression patterns related to stress response mechanisms, indicating the lasting impact of early experiences on later life. Ethical considerations emerge as we grapple with these complexities. Are individuals truly free to choose their paths in life, or are they constrained by biological and environmental determinants? The balance between advancing our understanding through scientific inquiry and respecting individual freedom becomes a central debate. This intricate relationship between genetic predispositions and psychological development challenges us to explore how narratives construct meaning from life experiences across different stages of human existence. In considering the role of narrative in shaping personal identity, we move towards examining how individuals narrate their lives, drawing upon past events and future aspirations to create coherent stories that define who they are. As children grow, they begin to weave these narratives with increasing complexity, incorporating both successes and setbacks to form a sense of self. For example, the narrative of resilience can be constructed by recounting difficulties overcome or challenges faced, which helps in developing a stronger identity. Psychologically, this narrative construction is not arbitrary, but is influenced by the brain's development during childhood. This development affects how individuals narrate their experiences, often with greater clarity and purpose. However, the narrative construction process is also shaped by environmental influences. A child who grows up in an environment that values storytelling may develop stronger narrative skills than one from a more pragmatic background. The ethical implications of this are significant. How we construct our narratives can influence our moral outlook and decision-making processes. For instance, someone who views life as fundamentally good may narrate events with a positive perspective, fostering optimism and resilience. Conversely, those who view it more negatively might focus on the failures and challenges, leading to different psychological outcomes. Biologically, the interplay between nature and nurture in narrative construction is evident. Epigenetic modifications such as DNA methylation and histone acetylation can alter gene expression without changing the underlying genetic sequence, directly influencing stress responses and overall well-being. This dynamic interaction suggests that both inherent biological predispositions and environmental factors contribute to how individuals narrate their lives. During this critical period between the ages of 2 and 4, a child's brain undergoes an intense process of neural plasticity. The formation of connections in areas responsible for sensory processing and emotional regulation is particularly robust during these years. However, the exact mechanisms driving this rapid development remain unknown, with limited understanding of how environmental inputs interact with inherent biological predispositions to shape cognitive and emotional capabilities. Ethical considerations arise when considering interventions aimed at enhancing cognitive development during these critical phases. Empirical evidence supports brain plasticity, highlighting that early experiences can profoundly impact an individual's later development. Yet, there is a philosophical standpoint that emphasizes the role of genetics and inherent biological factors in shaping who we are. In contrast to those born with minimal neural tissue, such as individuals affected by hydranencephaly, the brain's capacity for plasticity during early childhood remains a subject of intense research. While these cases demonstrate that environmental inputs may not fully compensate for severe genetic or biological limitations, they also highlight the complex balance between what is possible and what might be beyond human intervention. This dynamic interaction suggests that both inherent biological predispositions and environmental factors contribute to how individuals develop over time. The challenge lies in understanding the precise boundaries of these interactions and how they influence long-term development and well-being. Consider, for example, how early life traumas can lead to persistent changes in gene expression through epigenetic modifications that affect stress response mechanisms. These modifications are not limited to early childhood, but can persist into adulthood, thereby influencing an individual's resilience or vulnerability. From a psychological perspective, the brain's rapid development during early childhood is a critical period when environmental stimuli and genetic predispositions interact dynamically. For instance, exposure to high levels of cortisol, a hormone associated with stress, can alter gene expression in ways that affect cognitive function and emotional regulation well into adulthood. This raises profound questions about the extent to which our lives are predetermined by our genes versus being shaped by environmental experiences. The intricate relationship between genetic predispositions and environmental factors in early life is further complicated by the flexibility of epigenetic modifications. These changes can be responsive to a wide array of stimuli, including nutrition, maternal care, and social interactions. While genetics provide a foundation for individual differences, epigenetics reveal the mechanisms through which environment can sculpt that potential over time. This exploration into the nuanced interplay of nature and nurture challenges our understanding of personal identity and agency. This discussion sets the stage for examining how these processes shape individuals' experiences from childhood to death. The brain's complex interactions with its environment during early development lay down patterns that persist throughout life, influencing cognitive, emotional, and social outcomes in profound ways. This dynamic interplay challenges the purely deterministic view of genetics, as early life traumas can lead to persistent epigenetic marks that affect stress responses, influencing psychological well-being and behavior. For instance, consider the role of DNA methylation. This process can silence or activate genes without changing the underlying sequence itself, thereby affecting how certain traits are expressed. These modifications highlight the flexibility of gene regulation and challenge us to explore the intricate relationship between genetic predispositions and environmental factors. Ethical considerations arise as we contemplate whether and how interventions targeting these epigenetic marks might influence future health and behavior. This raises profound questions about the extent to which our lives are shaped by both heredity and environment, with no single answer definitively resolving this critical debate. As we move into later life stages, these early patterns continue to evolve but remain influential in shaping individual experiences. The psychological perspective on stress responses, for example, often includes a hormone associated with the fight or flight response, which can be deeply affected by epigenetic changes initiated during childhood. Children begin to grapple with the concept of mortality around the age of 4 or 5, a time when brain development and stress responses are undergoing rapid changes. This awareness can lead to anxiety, but also opens the door for deeper engagement with life's meaning. The role of narrative in constructing identity is intertwined with biological mechanisms such as epigenetic modifications. This flexibility allows organisms to adapt to new environments and experiences, challenging a purely deterministic view of human development. Stress hormones like cortisol, which are integral to the fight or flight response, can be upregulated due to these modifications during childhood. Ethical considerations arise as one contemplates free will versus determinism in light of these narrative and biological interactions. The relationship between psychological perspective and epigenetic mechanisms underscores the complexity of understanding human development over time. This balance between advancing knowledge and navigating ethical dilemmas is a critical debate that continues to unfold, inviting exploration into the nuances of life's mysteries from cradle to grave. This dynamic interplay underscores how early relationships shape an individual's cognitive development, even in cases where the brain retains limited plasticity due to genetic factors or conditions like hydranencephaly. Paul Sartre's philosophical standpoint reminds us that individuals define their narratives through these complex processes, highlighting the critical period when the brain undergoes extensive changes. This transition from childhood to death is observable across various realms of human experience, each contributing a unique layer to our understanding of life itself.